And welcome back for video number 2. Goal today is continuing to write and rewrite expressions in different ways, focusing on exponential expressions and simplifying when possible. So by the end of today, I would argue you can do this, you can do this, you could do the cube root of a to the 7th power. That would be our goal for this. Some reminders about basic vocabulary. Remember, a power is the entire thing, an expression that tells you to multiply a number times itself. The base, of course, is the repeated factor. The exponent will tell you how many times you multiply that repeated factor by itself. Now, as for roots, don't forget you're going to use that radical symbol. That would be the vocabulary for that. The index is going to tell you how many times the factor is repeated. Oftentimes we're used to seeing something without an index. Remember, if there is no index, it does mean a 2. The root, of course, would be the answer. The square root of 100 would be 10. The radicand is the number inside. And then the prime factorization of a number. So a reminder what we briefly discussed in a previous video. Let's say you're looking for the prime factorization of 50. Many of you would choose to use what's called factor trees. Kind of looks like trees with branches. Actually, the better method would be to bring that 2 down. That way you can see that every row should be 50. You have 50 in the top, 2 times 25 is 50, 2 times 5 is 10, 10 times 5 is 50. But I do know that some people just let it be and do not bring that 2 down, which is fine. Factor trees are one way of finding prime factorization. The other method is what I call upside down division. 2 goes into 50 25 times. 2 does not go into 25, nor does 3, but 5 does. And you can stop as soon as every factor is prime. Notice you'll have the same prime factors. So the prime factorization of 50 would, of course, be 2 times 5 times 5. That looks ugly. Reminder, please, also in the previous video, we stated that you might want to write down the first several prime numbers. Prime meaning a number that only has 2 factors, 1 times itself. So for instance, 2 is prime, 1 times 2. 3 is prime, 1 times 3. 4 is not prime, 4 is composite because you have factors of 1 times itself, but you also have a factor of 2 times 2, so that is 3 factors. 5 is prime, followed by 7, 11, 13, and so on. Note, please, that 1 is neither prime nor composite because 1 literally only has 1 factor itself. So let's carry on into a quick review. We're going to stop on the first page, but first, I bet I was going to cover that up and see if you could do number 2 and number 3. Pause the video, come on back when you're ready, please. So several different ways I'm thinking. First of all, 9 squared, of course, is 81. You could also rewrite it so that you take the 5th root of 9 first, followed by the 2nd or square power. You can rewrite that as an exponential, a rational exponent, that is, 9 to the 2/5, and surely there's other ways of writing that as well. Number 3, you could write the square power first of -64, followed by the cube root, but many of us might have noticed that the cube root of 64 is quite nice. So maybe you just change the order around and write -4 squared, which is 16. It does say write as a radical expression, which either of these would satisfy, and then simplify. That's where the 16 comes into play. Now we're going to do numbers 4, 5, and 6 together. If you want to, you can pause and try to get ahead of me. But I'm going to go ahead and I'm going to look at these problems, look at how they're similar, look at how they're different. They all have radical symbols. However, there's no index for number 4. That's going to mean a 2nd root. Meanwhile, for number 5 is a 3rd root, as is number 6. I further note that while some things are just plain beautiful, other things might not be. So some of you might immediately notice 6 times 6 is 36, and I'm going to expand out x times x times x, while others of you might have broken 36 down into 2 and another factor of 2 and a factor of 3 and a factor of 3. Its prime factorization would literally be 2 times 2 times 3 times 3, and then the repeatedly multiplying x's. Whether or not you put the dots is up to you. Point is here, ladies and gents, that we have 6 multiplied by itself. You could have written 2 times 3 outside. And then, oh, don't forget, Mr. Callan, we also have an x times itself, so the square root of x squared is going to be x. And then the only thing remaining inside is the square root of x. So we could rewrite this in simplest form as 6x multiplied by the square root of x. That would be the simplest form. Again, some of you will notice the 6 times the 6. Others of you might want to go all the way and say, well, 2 times 2 times 3 times 3. And if you pull out a 2 and a 3 factor, that will give you the 6. Number 5, I noticed something quite interesting. With the 216, I'm not going to actually break 216 down into all its prime factors because 216 is, as a matter of fact, the product of 6 times 6 times 6. I'll go ahead and expand out the x's, and I'll expand out the y's. And now we try to pull out, as the great Mrs. Willard talks about, any powers of 3. So for instance, I see 6 times 6 times 6 is going to equal 216. I see x times x times x is going to equal x cubed. But we do have an x left over. Hold on to that. Y times y times y is going to be the same or equivalent of y cubed, which means we do still need the radical symbol, but the radicand, the only number left, the only quantity left inside is going to be a single x. So final answer for number 5 is going to be 6xy multiplied by the cube root of x. Now we march our way on. And interestingly here, 24 is not a perfect cube. So let's go ahead and break down 24 is a factor of 2 is a factor of 24 and a factor of 12 and a factor of 6. And now I have all the prime factors. So if we were to break this down, this is going to take a lot of space. Let's go with 2 times 2 times 2 times 3. The product of 3 x's, or should I say x times itself 3 times, y times itself 3 times, z times itself 4 times. And now what we're trying to do here is note if the index is 3, are there anything that can be pulled out because they're multiplied by itself 3 times? I see a 2 here. Oh, and a 3 left over. I see an x can be pulled out. A y times itself 3 times can be pulled out. And a z as well, but with 1 extra z, which leaves us with the radicand of 3z. So final answer in simplest form there is going to be 2xyz multiplied by the cube root of 3z. Now pause the video if you need, go backwards. I'll tell you both number 8s are a no. I'm going to hope that you can explain why, but the video is going to get too long already. And I'm going to skip number 7, ladies and gents, although that is quite a good problem, but we'll skip it for now. If you'd like to, you can check in with my answer when we return. All right, that's the end of video 2. No, actually, let's do one more problem, and that is the tough SAT one. I'm going to give you a hint, and then I'm going to ask you to pause your video. Here's my hint, without giving away too much. All right, pause, come on back when you're ready. So if we were to rewrite the full expression and simply split it up into different pieces, you could see we could have 6 multiplied by the 5th root of 3 to the 5th, multiplied by the 5th root of x to the 45th, etc., etc. But one very nice part about splitting this up is that a power and a root are inverse operations. So you can then rewrite this as the product of 6 times 3 times x to the 5th, x to the 9th, times 2 times x, and I'm going to choose to rewrite this as a rational exponent. Now the reason for doing this is now you can go ahead and multiply the quantities together. 6 times 3 is 18 times 2 is 36. X to the 9th times x to the 1/8. Remember, when multiplying the products, you simply add the exponents, which is why you can write x to the 9 and 1/8. Very strange with a mixed number. We usually would write that as an improper fraction. But let's be honest, that's as far as we need to go to answer this question. If they're writing it as a times some x to the b power where a and b are positive, what is the value of a plus b? Well, a is the coefficient in front, that'd be 36. And b is the exponent, that'd be 9 1/8 or 73/8. And if you added them up, unless I am mistaken, which is always possible, I believe the sum of those two is going to be 45 1/8. Now, folks, that is one of the highest level of questions that you would find on the PSAT or SAT. So don't be intimidated by the challenge. Look at what we know about powers and roots, manipulate it in equivalent ways, and try to isolate the quantity in front of the x as well as the exponent above the x, and then answer that question. All right, folks, that's going to be it for now. Come on back for video number 3 in a moment.